Okay, so this box and whisker plot that we just drew is a picture of the spread of the data, of kind of like most of the data, right? And it gives us quite a bit of information. It tells us it's a good graphical representation because it tells us where the middle is, so it tells us where the median is, and it has these two other measures of something that we're going to talk about today. And the stuff we're going to talk about today is variation and position. So these three main huge objects in statistics are centrality, where the middle of the data is, variation, how is the data spread out, and position is about specific data relative, a specific data point relative to the rest. Like, where is it? Where is like this person in the data set, right? So here, this is a picture of variation, and it has two measures of variation. So if I go from top to bottom, one measure of variation is called the range. That's the max minus the min, right? And then we also have a measure of the interquartile range, which is between Q3 and Q1. Interquartile range. Q3 minus Q1. They both tell me something about how the data is spread out. Now, the standard deviation is also a measure of how far this data is spread out, so variation. There are different ways to measure this. I just want to be sure that you're kind of picking up different ways to measure. So this, like the range is one of them, this interquartile range. And then the standard deviation is a third way that we measure the variation of the data set. And it gives us one number that says, here's about how varied the data set is. And when standard deviation is big, it means kind of relative to the data points, it means that the variation is really big. And when it's small, it means kind of the data are packed close together. Okay. And we're not going to, we're going to use Excel today to calculate the standard deviation. You should maybe know it's based on something called just deviation, the deviation, which is when I take a specific data point and subtract the mean. And so the standard deviation is really sort of an average of the deviations, and we have to do some stuff to make sure that it doesn't, if I just take the straight average, it kind of gets messed up because I have positive and negative deviation. So we do something to just measure the overall size. But it's like an average of just where I take these data points and subtract them from the mean. Okay. And so the standard deviation has the most meaning. And if you want to know how to calculate this, I am happy to direct you to place, or just Google standard deviation. But it has the most meaning in the context of the normal distribution. And from your reading, you read about this normally distributed data, right? And so we have this kind of picture of like a perfect scenario, right? The normal distribution doesn't really exist in real life. In real life, we have data that's approximately normal. That's what we're looking at today. But then for the normal distribution, like this kind of fake, kind of idealized version, the mean, median, and mode are all in the middle, and they're all the same. For us, we'll look today and like they'll be about the same, but they're not exactly the same. And then here, when I use the standard deviation, so this is mu, the mean, plus one standard deviation. So mu is the mean. It's a Greek letter mu. Sigma is the standard deviation. When I add mu plus the standard deviation, and when I subtract the standard deviation, and I look at how much data is between these two, this should be symmetric, so pretend. When I look at the data that's in here, right, like this is a frequency diagram. The histograms are, this normal distribution is like a picture of frequency. When I look at how much data is in here, in between a plus or minus the standard deviation, I get 68% of the data. If I go out again to mu plus 2 standard deviations or mu minus 2 standard deviations, right? Now the green part, all of this, the green part is 95% of the data, is within those two bounds. And then when I do 3 standard deviations, please pretend these are symmetric. They're supposed to be. 3 standard deviations, which I'll do in yellow, but it's all of this stuff. And the yellow stuff is 99.7% of the data. And this is the 68, 95, 99.7 rule that people talk about. Then I kind of want to know where the data is. So for this data set that we're looking at, if you go to sheet 5, I made a frequency chart over here on the left. So I had Excel make this frequency table for me. The frequency table, the way you read it is like, if you look at 0, it has 0 things, because that's the beginning. But for this 1,000 piece, that means from 0 to 1,000, there were 2 data points in there. And so if I go back to the data set, you'll see it's these two, 271 and 328. Right? That's the frequency of those two. And then it goes from there. And then I graphed it, and I get something like this. Now, this is, again, approximately normal, because it's not smooth. It's not exactly symmetric, right? If I look back at what I found, the mean and the median are close, but not exactly the same, right? But this is approximately normal. Okay, so then I'm going to use Excel to calculate for this activity the standard deviation. And then I'm going to use it to answer these questions. So the standard deviation, let me go back here. I'm going to add one more standard deviation and then equal standard deviation. Now, so you'll see Excel has these .p, .s. These are for using the population versus if you have a sample. For us, these will be about the same, but they're doing slightly different things. I might use .s because I have a sample here. And then I'm going to select this, column G, close, and it will find the standard deviation for me, right? So this is 5,952. I might just round that to the whole number, 5,952. Okay, and then I'm going to go over here to my, and I'm going to type this in. Standard deviation. And then I want to find the 68% of the data. So when I find this, I'm using a picture like this. So I'm going to I need to know the mean, and then I need to know kind of what I'm looking for is these barriers, like right here. And then I know the 68%. So the mean in this case, I'm going to look back here, is 42,481. So I'm going to do this on my calculator. Actually, I'll do it right here in Excel. So I'm going to put mu plus the standard deviation. Let's see, 1 mu minus the standard deviation. And I'll just calculate this right here. So I do equal, and then 42481. I'll just round these, plus the standard deviation, 5952. And this is equal to 42481 minus 5952. You can do this with cell references if you want to. I'm trying to keep this a little bit simple. So what this means is, since I just subtracted one standard deviation, it means that 68% of the data is between these two values. I'm going to maybe do this, and then I'll do mu plus, I'm going to do these calculations. 2 standard deviations, mu minus 2 standard deviations. And so watch carefully, I'm going to do equal to the mean, 42481. Plus 2 times the standard deviation, 5952. 442,481. And then I'm doing minus 2 times 5952. This should be a minus. That's what I'm doing. And then we'll put these into the Word file. But I'm going to do this. And then the last one is mu plus 3 and mu minus 3. Okay, oops. Oh, I forgot to put the equal sign. See that? Equal. Okay. So now I'm going to, oh, I did that here too. I didn't even catch it. Okay. Now I'm going to snip this and bring this over to the Word file. And we'll fill this in. So in the Word file, I looked for these things because I want to know where 68% of the data is, 95, and 99. So I'm going to put this right here. Maybe make it a little smaller. But this mu, the 68% of the data should be between the mu, this first one right here. Oops, that's not what I want to do. This one right here, and like these two values. So I'm going to type that right here. This should be 36,529 and 48,433. And these are dollars, right? So these are salaries. So 68% of the teachers make between $36,500 and $48,400. 68%. That's amazing because it's like roughly 70%. It's a huge chunk. Okay, then 95% of the teachers are going to be in this next group. So like right here, I'm going to make it green. Those guys. Oops, that's not what I want to do. Now I got it. Okay. 95% of the day is between 30,577 and 54,385. 95% of teachers teaching in Common Core schools make this much money. And then the last one is between mu minus 3 standard deviations and mu plus 3 standard deviations. Now, do y'all see something bad happened here because these should not be the same number? So let me go back to my Excel file. What did I do? That's 3 plus. Did I forget to do 3 minus? I mean, they should actually be different. Okay, 24,625. Remember that. 24,625 and 6337. Right? So this is what the standard deviation means. When I say the standard deviation is about $6,000, it gives you a sense, and you also know that the mean here is about 42,500, right? It gives you a sense. So 42,500 with a standard deviation of 6,000, right? Gives you a sense of kind of where everybody is in this data. Okay, so then now I'll draw an approximate normal distribution of this data using this information both from the 68, this 95, 97 stuff, and also from the picture of the normal distribution that we just drew. So, okay, let me do that. So I'll just do this again. I'm drawing the same thing, except I'm going to put real numbers in here. So the mean is, what is this? 42. 481? Is that right? Wow, that's weird. Okay, 42, 481. That's right here in the center. Then I'm going to go out 1, 2, 3. 1, 2, 3 standard deviations. And so these are the numbers that we found. This 36, 529, 30, 577. These should get smaller, right? Because I'm going back a standard deviation every time. So every time I'm making a hop. So the distance here is 1 standard deviation. So the distance here is like a minus, what do we say our standard deviation? 5952. So I just subtract 5952. And then here I'm going to add 5952. But that's what I did. I already got these numbers. So this is 48, 433, 54, 385, and 6337, right? And then I'm going to draw in what I know. Same thing that I just did. This is 68%. Might do this. This is 95% in green. Oh. And then I guess we'll do this blue. This rainbow blue is 99.7%. And there's the normal distribution of this data, right? And again, it's approximately normal. I kind of have made this perfect. I've smoothed out the curve to kind of picture this. Okay. So now compare these statements to your box and whisker plot and write 3 to 4 sentences describing the relationship you'll see. We'll do that together in class in your groups. So, but if you want to write down some notes right now, we can.